Today we're looking at integrating trig functions, and remembering that integrating is just undifferentiating. It's going to be the reverse of the rules we learned when we were differentiating. So the integral of cos x is going to be sin x plus c, because this is an indefinite integral. And the integral of sin x is going to be negative cos x plus c. Now these rules are in your notes, so you're going to want to probably annotate those. Make sure that you remember them. There is a form of these on your formula sheet, but a lot of people find the form it's written in a little bit confusing. So it's kind of good to know. If you know the differentiation, then you'll be able to know the integration. It's just the same backwards. So when we differentiated sin x, we got cos x. When we differentiated cos x, we got negative sin x. Our first example on page 19 asks us to integrate 5 sin x plus 2 cos x. Now, there are no limits given, so it's an indefinite integral, which means I'm going to need to remember my plus c. And when I'm integrating, I can integrate each thing individually. So this is the same as 5 times the integral of sin x plus 2 times the integral of cos x. Now you don't need to write this line. I'm just writing it so that you understand how we're breaking it up. When we integrate sin x, we get negative cos x. So it's negative 5 cos x. When I integrate cos x, I get positive sin x. So it's going to be plus 2 sin x. It's indefinite, so it's plus c. Now I don't need to have 2 plus c's, because adding a constant here and adding a constant here just means that if I added those two together, I'd have another constant. So plus c once is enough. I am going to rearrange it so that I don't have that trailing negative. So 2 sin x minus 5 cos x plus c. Now the second example that we're asked for on page 19 has limits. It has an upper limit and a lower limit, so it's not going to have a plus c, and we're going to evaluate now that when we are integrating or differentiating trig functions, we must use radians, we cannot use degrees. Okay, so the second example is asking us to integrate 4 cos x plus 2 sin x between the limits of 0 and pi over 4. So I'm going to go ahead and integrate. Cos x integrates to sin x, so I'm going to have 4 sin x. Sin x integrates to negative cos x, so I'm going to have minus 2 cos x. And I'm going to be adding my limits here. And now I am going to substitute. So upper limit first. So 4 times the sine of pi over 4 minus 2 times the cos of pi over 4. Take away 4 times the sine of 0 minus 2 times the cos of 0. Now, I'm going to have to evaluate these two expressions here. So I need to know what the sine of pi over 4 is, I need to know what the cos of pi over 4 is, I also need to know what the sine of 0 is and the cos of 0 is. So I'm going to use an exact value triangle for this bit, and I'm going to use my sine and cosine waves for this bit. So the exact value triangle that I'm using is the one that was a square chopped in half, so it's a 1 by 1 using Pythagoras. I remember that side's root 2. The angles were right angles, they've been cut in half, so they're 45 degrees, or pi over 4 radians. Now, the sine of pi over 4 is SOHCAHTOA, so opposite over hypotenuse. Opposite the 45 degrees is 1, and the hypotenuse is root 2. So here I'm going to have 4 times 1 over root 2. And I'm subtracting 2 lots of the cosine of pi over 4, and k is adjacent over hypotenuse. Adjacent is also 1, hypotenuse is root 2, so that's 2 lots of 1 over root 2. That's my first bracket. Now in the second bracket, I'm going to have a little bit of a look at my waves. So y equals sine x looks like this. The sine of 0 is 0. For the cosine, it's different, and the cos of 0 is actually 1. It starts at 1. So back to here, I've got 4 times the sine of 0, which is 4 times 0. Take away 2 times the cos of 0, which is 1. So 2 times 1. Now, I've got 4 times 1 over root 2. Take away minus 2 times 1 over root 2, which is going to leave me with 2 times 1 over root 2, which is 2 over root 2. And I'm taking away 4 lots of 0, which is 0, minus 2 lots of 1, which is minus 2. Because I'm taking away a negative, it's going to be adding. So I'm going to have 2 root 2, 2 over root 2 plus 2. Now, this is the answer, but to tidy it up, really we want to rationalise that denominator. So remember, that means we don't want a third on the bottom. So to get rid of the third on the bottom, we multiply that whole fraction by root 2 over root 2, which is just 1. Anything over itself is 1. But the thing about multiplying that is I'm going to be able to multiply the root 2 times root 2, and that will give me the actual number 2. And that's what I want. I want a whole number on the bottom. So I've got 2 root 2 on the top, 2 on the bottom, plus 2. And now, of course, I can cancel out those 2's. And all I'll have is root 2 plus 2, or 2 plus root 2. Okay, if you're not sure about the surdy things, ask me about it in class. Okay, so let's just check that we've understood what's going on. What is the integral of 4 cos x? Should we be using degrees or radians when we're doing this type of calculation? And can you draw your exact value triangles from memory? You are going to need these for this as well as your trig equations and all the other bits and pieces that we've been using them for. We're now able to do exercise 14C, and question 1 is unit level. Question 2 to 4 are C, and question 5 to 7 are AB.